Hello everyone, welcome to the video on solutions of the assignment 3. So we'll see the solutions of these numericals one by one of the inverse Laplace transform. Okay, so the first example where we observe there is 1 by s log of s square plus 9 upon s square plus 16. Just ignore that outside 1 by s and you focus on log function here. So for this log function, we already know whenever there is a log, tan inverse or cot inverse, we should use the inverse Laplace by derivative property. So let me start with here that our fs is log of s square plus 9 upon s square plus 16. So this fs can be simplified as we use the property of log as a log a minus log b, and we can get fs as log of s square plus 9 minus log of s square plus 16. Now, to remove this log function, we'll take a derivative. So f dash s is 1 upon s square plus 9 into derivative of s square plus 9 is a 2s minus 1 upon s square plus 16 into 2s. So that about f dash s we have. Now, uh, just our aim is to get fs mainly. Fs will be the L inverse of that f dash s only. Uh, our aim is to get that f of t, which is L inverse of fs. So taking inverse Laplace on both side, taking inverse Laplace on both side, L inverse of f dash s. Now we use a property. L inverse of f dash s is a minus t ft. That is L inverse of f dash s. On the other side, this 2 is a constant and L inverse of s upon s square plus 9 is a cos of 3t minus cos of 4t, is it? So we won't require that L inverse of fs, which is f of t, and that become 2 times. So this minus sign will merge on in the numerator, so it become cos of 4t minus cos 3t upon t. So that about L inverse of fs. This is actually L inverse of fs. Okay. And lastly, if you observe the given function that we have, this is a L inverse of, if you observe this function, if this log is fs, so this is fs upon s. So lastly, we use one property by division by s property, by division by s property, L inverse of that fs upon s. See, division is related to the integral. So it's integral 0 to t ft dt. Ft dt, because Laplace of the integral 0 to t ft dt is fs upon s. So the final answer is integral 0 to t cos of 4t minus cos of 3t upon t dt. That is the end of a question. So this is the answer. This is the L inverse for, this is the L inverse of 1 by s log of s square plus 9 divided by s square plus 16. So that is the end of a question here. Okay, so you got here, this is the answer. So you can highlight it. So no need to evaluate this integral. Remember, this integral is integral from 0 to t there, this integral. And you cannot evaluate. You will not able to evaluate that integral. The final answer is in integral form only. Okay, so that is a question number 1. Now we'll move to the next example. Here is the example 2, where we have to find out the inverse of s square minus 2s upon 3 upon s minus 1 bracket square upon s plus 1. So this is one of the rational function, and for rational function majority of the time first we have to focus on the partial fraction method. So we'll start assuming a partial fraction. Let this given expression is a upon s minus 1 plus b upon s minus 1 square plus c upon s plus 1. We already observed two of the coefficient we can get it by shortcut method. So the coefficient b and c, because for getting a, shortcut method fails. So I will write this as a upon s minus 1 as it is. Okay, to get the value of b and c, okay, to get the value of b and c, see the b is equal to, ignore the denominator of b, we left with s square minus 2s plus 3 divided by s plus 1 and at s equal to 1, at s is equal to 1. So we'll replace that s by 1 there. So this 1 minus 2 plus 3 divided by 2. So you'll observe 4 minus 2, this is 2 upon 2, that is 1. So we got the value of b as 1, so 1 upon s minus 1 bracket square. This is the rough work we are doing. So similarly we get the value for c as s square minus 2s plus 3, okay, divided by s minus 1 bracket square at s equal to minus 1. So to replace s by minus 1, this is plus 1 plus 2 plus 3, 6. So that will come as a 6, and minus 1 minus 2 square is a 4. So this is 3 by 2. 3 by 2. So the value of c is a 3 by 2 into 1 upon s plus 1. Only the thing that a is left, and to get the value of a there is no option other than cross multiplying. So if you cross multiply now, we get s square minus 2s plus 3 is equal to a into s minus 1 into s plus 1. Okay, so we are multiplying here, plus that 1 into s plus 1 only, plus 3 by 2 into s minus 1 bracket square. So here we get that expression which valid for infinitely many values of s. So we'll put here simplest value that is available is s is a 0, which we not used already because we use s equal to 1 and s equal to minus 1. So we use s is a 0. If we replace s by 0, we get 3 is equal to a into. Now you'll observe this is a minus a because s is a 0. So minus a plus 1 and plus 3 by 2. So you'll observe 3 by 2 plus 1 is a, so I'll take a on the other side. A is equal to this, this a on this side. This is a 5 by 2 minus 3. So minus 6 minus 1 by 2. So here we are in the last part now. We replace the value of a in this one and we get thus we left with L inverse of the value of a minus 1 by 2, 1 upon s minus 1 plus 1 upon s minus 1 bracket square plus 3 by 2, 1 upon s plus 1. So the most important task is to get these values of a, b, c. That is a little lengthy always. And now only two steps left. Just we use the standard result. This minus 1 by 2 is a constant like this. Inverse of 1 upon s minus 1 is a e raised to t. Inverse of 1 upon s minus 1, see, first of all, s minus 1 square is there. By shifting property, it is e raised to t into L inverse of 1 upon s square. Inverse of 1 upon s square is a t raised to, yes, it is a t raised to 1 because inverse of 1 upon s raised to n plus 1 is a t raised to n upon gamma n plus 1. So it is a gamma 2 or t raised to 1 upon 1 factorial plus 3 by 2 e raised to minus t. So the final answer for the example 2 is, I'll write a positive term first, t into e raised to t minus 1 by 2 e raised to t plus 3 by 2 e raised to minus t. So that should be your answer. Okay, that is the answer for the example 2. Third example, see again the question, again the example is a rational function. So whenever rational function, try to find out the factors of the denominator. So numerator, we will not do it anything. 2s square plus 5s minus 4. From the denominator, I can take s as a common and we're left with s square plus s minus 2. See this quadratic equation whose constant term is a minus 2, so there will be two factors whose multiplication is 2. So factor can be 1 minus 1, 2 minus 2. One of that is a minus factor because minus coefficient is there, and one of that should be a plus. So if you replace s by 1, if you replace s by 1, you will observe that is a satisfied. So 2s square plus 5s minus 4 divided by that s is there. If you replace 1 plus 1 minus 2, so s is 1 is a root, so s minus 1 is a factor. Now if I replace s by, see, first root we taken a positive, so there is another negative root, so minus 1 not satisfied because it is a plus 1 minus 1 not 0, minus 2, this is a plus 4 minus 2, so minus 2 is a factor, so s plus 2. So this is mainly the important task now, getting the roots of the denominator. You can get it on calculator also, scientific calculator. Then partial fraction is a upon s plus b upon s minus 1 plus c upon s plus 2. And this is one of the simplest example. The reason is all factors are linear and distinct. Linear and distinct. So we get the value of a. To get the value of a, we ignore the denominator of a. We left with 2s square plus 5s minus 4 divided by s minus 1 into s plus 2 at s is equal to 0 by equating the denominator of a to the 0. We replace that minus 4 upon minus 2, so which comes as 2. Now to get the value for b, yes, 2s square plus 5s minus 4 divided by now s upon s plus 2, where we replace s by 1. If we replace s by 1, so this is a 2 plus 5 is a 7, 7 minus 4 is a 3, and here it is a 2 plus 1 is a 3, and the value of b is 1. And lastly, the value of c, which is a 2s square plus 5s minus 4 divided by s into s minus 1, where s is a minus 2 now. So minus 8, sorry, not minus 8, 2, this is a 2 minus 2 square is 4, 4 to 8, 8 minus 10, sorry, 8 minus 10, correct, minus 2 minus 6, and here s is a minus 2, so it is a minus 3, minus 3 into minus 2 is a 6, so it is a minus 2. That's the end one. So we got ABCs now. Just we replace. Thus we have to find the L inverse of A upon S, which is 2 upon S, plus B upon S minus 1. C is a minus 1. So that about the replacement. And the last step now, by a standard result, L inverse of 1 by S is 1 only, so it is a 2. It is a e raised to t, and this is a minus e raised to minus 2. So this is the answer. That's only the answer. Okay, so final answer of this example 3 is this one. Question number 4 here. In the question 4, actually one linear and quadratic term is there. So the partial fraction go like this: a upon s plus 4 bs plus c upon s square plus 9. Here we have to find the values of a, b, c. Now to get this a, b, c, yes, obviously the value of a we can get it by shortcut method. Just we replace that. Just we replace. Sorry, s plus 29. We ignore that factor. We get s square plus 9, where s is a minus 4. So 29 minus 4 is a 25, is it? and 9 minus 4 is a 5, so a is a 5. So value of a, yes, we get it by shortcut method. Therefore, by cross multiplication now, s plus 29 s plus 29 is equal to the value of a is a 5 into s square plus 9 bs plus c into that s plus 4. So this is actually example number 4 is there. So this is not 3, it's the question 4 of assignment. So here, to get the value of a b and c, we have to put some values. One of the value minus 4 we used. So simplest value is s is a 0. If we replace s by 0, we get a 29 is equal to, this is 45, 9 5s are 45. So plus 4c. So that 4c, 29 minus 45. 30, is it a 16 minus 16? So uh, so c is minus 4. So value of c we received here. Now to get the value of b, one last. So again another simplest value, we put s is 1. We replace s by 1. 30 is equal to 9 plus 1 is a 10. 10 5s are 50. The s is 1, so it is a b minus c. B plus c is there, so b minus 4 I've read, so value of c, and this is into 5. So 30 minus 50 is a minus 20. Minus 20 divided by 5 is a b minus 4. So 5 fours are minus 4. So b is a 0. Correct? Let I check here. 30 minus 50 is a minus 20. Minus 20 divided by 5. 5 fours are 20. Minus 4. This minus will become plus 4. B is coming 0. Generally, never happens. The reason is one quadratic factor is there. So in this case, that okay. So whatever we received, so just do not make any silly mistakes in calculation, and we left with now b is a 0. So we left with the value of ABC will replace here in this expression. So a is a 5 and c is a minus 4. Okay, we left with L inverse of 5 upon s plus 4 minus 4 upon s square plus 9. Is it? You should check. So the next step is standard result 5 as it is, 5 into e raised to minus 4t. Here we should adjust 3 in the numerator. So minus 4 by 3 sine 3t. That is the answer. You can cross check also whether this answer is correct or not. What you can do it, you will find the Laplace of this function, and you should get that whatever fs we are given. So that is the answer for example 4. Example 5, it's not so simple. It's a fourth power. Okay, it's a fourth power example. So here there is adjustment we require. This fourth degree equation we can convert in quadratic by adjustment. So we can take s upon s4 plus 4a raised to 4. So I will add the middle term, which is a 2s square s square, 2s square s square. The same term I will subtract here. Now what is the benefit of this? The benefit is this become a complete square. So we get here s upon s square plus a square, s square plus a square bracket square. So you will observe s4 plus 2a square s square plus s square plus 2a square. My mistake. Okay, 2a square bracket square. Now this is minus 2a square s square as it is. So we can simplify this again further with s upon, this is like a square minus b square. The factors are a minus b into a plus b. This is s square plus 2as plus 2a square. So this is actually a square minus b square is there. So I am taking a plus b into a minus b. So s square minus 2as plus 2a square. Again, this is a quadratic term where we should make a complete square. So if we go for complete square of the denominator, we get s plus a bracket square. You will get s square plus 2as plus a square. So plus a square is there, so you should take minus a square here. Similarly, here s minus a bracket square, uh, and here also plus a square. Sorry, this is again plus a square. My mistake. Is it correct? S square minus 2as plus a square. And now you'll observe denominator s. Denominator s. Here is s plus a. Here is s minus a. So what we have to do it, we have to first use a partial fraction. We have to use a first partial fraction, which will be say as plus b, because the denominator have the quadratic term, numerator have the linear term, so that creates again a problem. Generally, such a lengthy examples never come in the exam, but yes, you should know, you should be aware how to deal with these complicated problems. So here is no alternative now other than, if every s is in the form of s plus a, okay, s plus a, what we can do it, we can use a shifting and straightforward way, but here uh, one of the bracket is s plus a square, other is s minus a square, and hence we have to write a partial fraction for this, separate it, and then we take an inverse Laplace. So the partial fraction will be a upon, is it a, no, as plus b, as plus b upon s plus a bracket square plus a square plus cs plus d upon s minus a bracket square plus a square. A little lengthy, but yes, there is no alternative. Now the main aim is to get a, b, c, d, and to get all these four values. Now remember, no shortcut method, nothing is there, cross multiplication and simplification. So what I will do it, I will cross multiplication and put some values, say s is equal to 0, plus 1, minus, don't put plus 1, minus 1. You put s is equal to 0, s is equal to a, s is equal to minus a, then s is equal to 2a. These four values are enough to get a, b, c, d. So I will give that as a your homework for getting this a, b, c, d. I will directly give you the answer in terms of ABCD. Find out ABCD by putting s equal to 0. So I will say A, B, C, D. You have to find out by putting s by 0, s by A, s by minus A, and s by 2A. So you get four equation for four unknowns, and you get the ABCD values. So this is the homework for you that you have to do it your own. So we come across L inverse of. If you observe the first term, we can write whatever the s is there. So you can take s plus a there, s plus a minus a, and you write e raised to minus at out. With number, it becomes easy now if we have that a, b, c, d. So this is s plus a minus a for the first term, and you will get the answer. The answer will be in this form. See, s plus a I'm talking as e raised to minus at out, e raised to minus at out, and we get L inverse of this is s plus a minus a. So into that capital A, okay, a times that one, plus here is a plus a minus a, that adjustment we require. So minus small a into capital A is there. Oh, sorry, my mistake. This e raised to minus 80 into capital A, denominator will be of that is that then we left with s upon s square plus a square. S upon s square plus a square is cos 80. So that will be a first term. Then minus capital A into small a, which is 1 upon s square plus a square. See, this e raised to 80 will be multiplied here, my mistake. So minus a into a, and 1 upon s square plus a square is 1 by a sine 80. So this a is not required. So a sine 80. As I'm doing direct, na, it is making some mistake. A can be taken common. Okay, this is for the first term, but there is plus b also. So that plus b, so b minus a. So this coefficient you get it as a plus b minus a. I'm doing directly. Okay, so remember this question generally never come in the exam. Don't worry. Don't worry. It's a too complicated, too lengthy. Okay. Uh, so similarly, the answer for the second, you will get plus. Now here is e raised to 80 will common. Exactly similar solution. You will get c into s upon s square plus, that is cos 80, plus is minus a plus a um, plus a plus d plus c sin 80, something like that. Okay, you will get some solution like this. Okay, so that will be your answer. Don't worry. Even though it is written direct, it is too lengthy, so it is ignored. Okay, so it is for just those who are interested, they can try it and complete it. Okay. Sixth question, sixth example is again a log function. Whenever log appears, we already know we should use derivative property. So we'll start with fs. Fs is equal to log of s square plus 1. There is s, so minus log s, and there is into is there again, so minus log of s plus 1. So there are three things. So we get f dash s here, 1 upon s square plus 1, that's a derivative, into 2s, minus 1 by s, minus 1 upon s plus 1. Now we have f dashes, so taking inverse Laplace on both sides, L inverse of f dashes is a minus tft, minus tft. To get this one, 2, this is a cos t, minus 1, minus e raised to minus t. So we have the answer here, f of t. This minus sign will merge in the numerator. So it is 1 plus e raised to minus t minus 2 cos t divided by t. So this will be the answer. This is one of the simplest example that we have. It is a inverse Laplace by derivative property. Okay, that is the end of the example 6. Seventh is again a little complicated because it is a tan inverse 2 by s square is there. If it is just 2 by s, that's okay. Uh, so for seventh example, I think let me check uh, whether there is one property tan inverse plus cot inverse. Yes, it is 5 by 2. That is okay. But here we have tan inverse, and to remove tan inverse, we can use a derivative property. Um, So can I write? It is better. So this is our fs. So let fs. It's not complicated, I think. Let fs is a tan inverse 2 by s square, which is nothing but cot inverse of. Is it correct? Check. Cot inverse of s square by 2. Check this expression. Okay, whether it is correct or wrong. So this is a cot inverse. So just we taken a reciprocal here. So tan inverse x is equal to cot inverse 1 by x. Okay, tan inverse x is a cot inverse 1 by x. You can easily prove. I will erase that. So here I will do that part. So see, tan inverse x is equal to cot inverse of 1 by x. Is it true that we used? Yes, because if you take on the other side, you'll observe cot x is equal to tan of 1 by x. Tan of 1 by x. So cot x is always tan of 1 by x. Is that relation exist? Yes or no? That you should check. You should check. Is it true or false? Is it true or false? Cot means cos x upon sin x is equal to cos of 1 by x upon sin of 1 by x. Is such a relation is there? Yes or no? I think no. No, somewhere we are making mistake. This relation doesn't hold. Doesn't hold. So that is the wrong thing I'm doing here, probably. So if the relation is there, yes, we can do it, but better we use derivative property direct. So there is no relation like that. So don't worry. So f dashes derivative of tan inverse is 1 upon 1 plus 4 upon s raised to 4 into the derivative of 2 by s square will be minus 2 upon minus this is a minus 2 upon s cube, but already there is 1 2, so 2 upon s cube. So we'll minus 4 upon s cube indirectly. So when this s square, so is it 4 upon s raised to 4? It is a 1 upon x square plus a square. 2 by s square square is 4 by s 4. That s4 goes in the numerator. So minus 4s upon 4 plus s raised to 4. So now this is the problem. Again, you will observe this is in the form of s upon s raised to 4 plus a square. Okay, this is like example number. This is the example number 6. Sorry, 5. This is s upon s raised to 4 plus 4a raised to 4. So that type s upon s raised to 4 plus 4. So here also you have to go that way. So this is always complicated. This is always a complicated. So where you can write like minus 4s upon, this is a s4 plus 2s square, s square plus 2s square plus 4. Okay, yeah, I will not drop the step here. So just we our aim is to make the complete square. So s4 plus 4, here we add 2s square term, 2s square and minus 2s square, and in the same way minus 4s upon this 2s square gets cancelled, so indirectly we get s square. See, s square plus plus root 2s plus 4 and into s square minus root 2s plus 4. Complicated again, so don't worry, this type of example will not come. Just refer above example 5, example 5 for the remaining part. But again, you can ignore this question because of 2 by s square. Just tan inverse 2 by s. If there is a tan inverse 2 by s, yes, you can do that, and that type of example can come in the exam also. Okay, so you can ignore this also. Okay, so that about the 7 examples of the assignment 3. Those who completed, it's good. You can cross check your solution. Okay,